Hi everybody, we're back. It's Equinix at KubeCon 2024 in Paris. I'm joined by Dave Neary. Hi.
Hello.
You are the Director of Developer Relations at Ampere.
Yes.
Okay, so for folks that don't know, what is Ampere?
Well, Ampere is a CPU company. We make general purpose CPUs, which we call cloud native CPUs. So they're CPUs that are designed, or CPU cores, I should say, that are designed from the ground up specifically for the needs of cloud computing. So we go for very high core density, very high memory bandwidth, single-threaded cores so that you don't have any noisy neighbor issues. You don't want to be running an application in the cloud and have your application slow down because some other customer is running something on the same physical core as you. So for all those reasons, we call it cloud native CPU.
Yeah, okay. And you guys use the ARM architecture, right?
That's right, yeah, it's ARM64. Yep. Although in our latest generation processor, Ampere One, we design our own cores. So we use the ARM ISA instruction set architecture. Okay. But they're our core designs.
Oh, so you're making your own cores now. Okay, cool. That's very neat. All right, so with your latest thing, what's the big new thing? What makes this gen pop?
Well, certainly there are three types of workloads that we really think fit really well on our processor, right? One is all of the workloads that are CPU bound, so web tier, signal processing, that kind of workload, work really well on Ampere processors. We have a big focus right now on AI inference, which we had a mention in the keynote today.
I saw that, yeah.
And I would say the third large aspect is around in-memory databases, which tend to be much more memory constrained than I/O constrained, and tend to run really, really well on Ampere processors.
Cool. All right. So now you do developer relations at Ampere. So I do some developer relations and the software side of things, some integrations with software. How does that vary with the hardware side of things?
Well, we're aware that we're a relatively new processor company, and you need to give people a reason to use your product. So our customers are cloud service providers, hosting companies, large enterprise. People who are already hosting large quantities of hardware on the cloud. And we want to get their customers using our processors by choice, right? Which means creating an incentive to do that, which means understanding what workloads people want to run, or what runs best on our hardware, characterizing that, and creating kind of success stories for people who are using our processors, and really just creating that momentum for people to see the advantage of running on ARM64 cloud native CPUs.
Cool. So, say I want to do some AI stuff with the Ampere software, with the Ampere CPUs, because quite frankly, I can't get the GPUs. They're too expensive.
Right.
But these ARM instances are coming up and they seem pretty cost effective.
They are.
But CPU and AI always seems like they equal slow in my head. But my understanding is the Ampere CPUs, they've got some magic in them around the supporting materials you provide to kind of make that go a little smoother.
So I would say, first, we've benchmarked the Ampere CPUs for AI inference workloads, and for a large number of workloads, we're 80% more cost efficient, so price performance. So you're saving a huge amount of money. So there is a performance aspect there, but the price aspect is really what outweighs the performance aspect in many cases.
If I can wait, I'll save so much money by just,
Correct.
Yeah.
But also, we have a strong focus on AI inference. So for those who aren't aware, AI training is how you create the weights for a model. It's floating point intensive, it's compute intensive, it uses a lot of GPU. And in general, it takes a long time, and it's very sensitive to initial conditions. However, once you have a trained model with a set of weights, running that model over and over again is a relatively cheap operation. So what we found is that a large number of those AI inference workloads, particularly on the smaller models like 7 billion or 50 or 13 billion tokens from Llama, for example, those run absolutely fine, to an acceptable performance, I would say, when running on general purpose CPU, and you're saving 80% of the money that you would spend if you were spending on GPU.
All right. So I've played around with some of these inference models in the past, and and this has changed so much just over the past 2 years. Like trying to get like something like Stable Diffusion to work on a MacBook or an AMD GPU, because it wasn't the big popular GPU that everyone's using. Like there were no instructions, it was so hard to do. What are you guys, since you have a platform that's even more like, I don't want to say out there, but like people aren't necessarily already running on it, so they're not used to it. Like what do you do to support them to get them up and running with these inferences?
Well, so there is a hardware and a software angle, right?
Okay.
So on the hardware angle, the hardware is designed with workloads like AI inference in mind. And I talked about some of the features that are relevant in that already. And then on the software side, we have optimized versions of popular frameworks like PyTorch, TensorFlow, and ONNX that are specifically optimized for our platform and for ARM64 in general, but specifically for Ampere processors.
Okay.
Which really enable you to get massive improvements in price performance without a massive degradation in performance. You may have to throw more cores at it, but compared to the amount of cost and the amount of power that a GPU consumes, being able to use general purpose CPUs and SDRAM or DDRAM rather than a GPU RAM with GPU processors, GPU cores, is a real money saver.
Yeah, what it comes down to. You need to save that money. All right, so what are you guys announcing at the show? Anything, or are you just here to support everybody? To just be like, hey,
really,
we're here, we know you need us, let's get it going.
So, Ampere and Equinix have been working together around the CNCF space for quite a while.
Yeah.
As you know, Equinix provides bare metal credits to the CNCF projects.
Yep.
6 months ago, Ampere and Equinix and CNCF launched a pilot of a product called Actuated, which provides hosted GitHub runners for CNCF projects. So what that means is that for projects who want to use GitHub Actions for their CI/CD, and there are many in the CNCF, they add one line. They just create a new runner type for their GitHub action, and their builds are just running on ARM64 VMs. They're running on Ampere hardware hosted by Equinix. And so we're improving build times, improving security, because running in single-use VMs that you bring up and tear down after a build
go away. Okay.
Gives you a much more build chain than if you're reusing a host environment from one build to another, with having potentially side effects between the runs. And then we're also concretely improving ARM64 support in projects like OpenTelemetry, for example, where it was a net new addition to the project.
Okay, so if I'm here at KubeCon, there's a good chance I might be a maintainer of one of these CNCF projects, and I want to start leveraging these actuated build environments. Where do I go to find out more about that?
Well, what we launched in October was a pilot.
Oh, all right.
We would like to expand the pilot, but that is a little bit more of a complicated process. I will say, one of the other announcements that came out of KubeCon in Chicago was Oracle announcing a large number of ARM64 credits on OCI.
Right.
Yeah. So that is another option. I would say Equinix ARM credits, OCI, and OCI ARM credits are the two best ways to get started on ARM64 builds for projects.
So, all right. So you're at KubeCon. Do you get to see anything or jump into any sessions or anything while you're here, or do you have the booth?
Well, today I've been pretty busy.
Yeah.
We got a lot of interest after the keynote, so I've been helping out with some media interviews for our keynote speaker, Victor Jakubiuk, who runs our AI team. I mean, some of the things that are happening this week I'm really excited about are things like Fermyon is demoing their WASM platform running on ARM64 and x86 on their booth just over here. We've been talking to a number of people who are doing things like CI/CD is a use case that we're really interested in and kind of pushing hard on. GitOps is one of the ways that you can ease the addition of an extra platform to your existing infrastructure. And so we're very interested in working with a lot of the GitOps companies that are around here. Acuity is an example. ArgoCon was a really good conference yesterday. So I'm excited about Argo. I'm excited about Cilium and BGP. That was one of the things or not BGP, eBPF.
Oh, okay, that makes more sense. All right.
That was one of the things that was an advantage of working with Equinix and Ampere for those projects like Cilium and Falco that use eBPF, is that they were able to get custom kernels built by Alex Ellis and his team working on Actuated to do all of their CI on ARM64. So I'm excited about the potential of eBPF in the industry to like radically change the way we do observability and network policy management, and storage policy management, and et cetera. So yeah, no, there's a lot going on this week, and I think eBPF related projects, obviously AI inference, and WASM related projects, and CI/CD, GitOps related projects are the ones where I'm really, really excited to see what's going on.
Okay, yeah. So you probably just get to talk to people all week. You don't get to actually go to
Pretty
sessions,
much.
I assume? Okay, all right, so.
Well, today at least.
Well, at least not today.
Maybe tomorrow.
Should try. All right. So what's a good way for someone to know, like, hey, I've got a workload that I really should reconsider about whether or not I'm doing on x86 or start looking at the Ampere stuff or whatever.
Well, I can give you some examples of the types of workloads that we're seeing running across different infrastructure providers. So generally, stateless workloads, one example that comes to mind is a company called OpenX is running their ad engine. So this is when somebody loads a web page, they want to match as an advertiser with the user and the user journey that person is going through. So they run a real-time auction. Their latency there is 200 milliseconds from getting a web page loading to having an ad returned to it. They run all of that real-time auction piece on ARM64's hardware, on Ampere hardware, and are saving about 30% on their cloud bill for that piece of their infrastructure. Another example is a local French company, Amadeus. So this is a travel company. They're kind of the search engine behind all of the travel websites for things like hotels, flights, and so on. And they run all of their search engine functionality on ARM64, on Ampere, and also are saving, I think, about 17%. So they see a 17% price performance or performance per price.
Is that 1.7 or 7.0?
1.7.
Oh, 1.7, okay.
Yeah, which is still a significant improvement. It's not 30. I would like to see 30 everywhere. For in-memory databases, we have a project called Memento. This is based on the open source Apache Pelican cache. So this is a cache as a service, and they handle. One of the things that they really care about is tail latencies. So they want to make sure that the 99.9% user of their platform has less than a 20 millisecond latency on a get for an object that's stored in their database, and they can get that with less compute resources because they run Ampere processors at a higher load before they scale out than they would be able to run x86 processors. So they save about 30 to 35% on their cloud bill as well.
Awesome.
So that's just a few examples of people who are different types of workloads. Again, as I said, in-memory database, web tier applications, stateless cloud-based applications. CI/CD is a great workload for running on ARM64, particularly if you want to run your application on ARM64. It's a good idea to build it on ARM64. Yeah, I mean, that goes without saying, right? And then AI inference is a really big one as well. So we have examples across all of those where people are saving tens of percent. Sometimes it's as low as 20, sometimes it's as high as 80 on what they would be spending otherwise on GPU instances or on x86 instances.
It's amazing. All right. Is anything exciting coming down the pike for Ampere or anything that we can hint at?
I don't know if I can talk about anything in particular. I'm
right.
interested to see, so we announced last April, I guess, the general availability of Ampere One, which is our next generation processor, and we're starting to see Ampere One based products come on the market now through hosting companies like Google, Oracle, and through OEMs like Supermicro. And I'm interested to see how those do in the market when they come out. when they become more widely available.
All right. Well, that's Ampere. Thanks for joining us. Thank you, Dave, for joining me.
You're welcome.
Stay tuned for more KubeCon EU 2024 with Equinix here in Paris. Until then, see ya.